to see.
Is that
Why
for
they
me?
not?
Yeah.
It's so cute. I think it's fine when the great semester too. Please keep in touch.
Oh, thank you.
Please.
I
Do the
got
underlying
it
quotes.
happy even if it is old. It's so cute. Like,
We need to find out his birthday.
Okay, this is the last tutorial class in this semester for this course. So this is the last worksheet, and you can see in this last worksheet there are 5 questions. They are all related to the 2 sample test. So before we work on the worksheet, here is a summary of the formula and the procedure to do the test. And they are all, you can all find all this formula from the lecture notes or lecture videos. I just summarize them in this page. So for 2 sample problem, we would like to compare. We do the 2 sample test just because we want to compare. We would like to compare 2 population mean, for example. Then the null hypothesis will state that the 2 population mean from 2 populations are the same. And similar to the 1 sample test, we will also have different way to do the test according to what information we are provided. If you are told that the sample were drawn from the normal distribution with the population variance also provided, they are known, then we will do the so-called z-test. With the test statistic given as the ratio of the difference in the sample mean divided by the standard error of this difference. So in fact, this test also have the similar formulation as the 1 sample test. Because we also have a null value for comparison. The null value, intrinsic null value is 0. So we have the difference in the population mean. We are actually testing whether this difference is equal to 0 or not. So the test statistic also takes a similar form. We are actually comparing the estimate of the difference to the null value in the null hypothesis and standardize it using the standard error of the estimate. So from the 1 sample test, you see the test statistic also take this form. Now, after we compute the test statistic, we need to determine whether the hypothesis should be rejected. So we need to define the rejection region. Now it also depends on the alternative hypothesis. So the rejection region is determined according to your alternative hypothesis. It depends on the objective of the test. If we are doing the 2-sided test, that means we are testing toward both sides of the null value. Okay? It is actually testing toward both sides of 0 in terms of the difference. So similarly, we also have this 1-sided hypothesis equivalently in this form. So accordingly, we will determine the rejection region comparing the test statistic with the normal quantile. If we are doing a 2-sided test, then we will only take the magnitude. So no matter this z computed is negative or positive, we will just drop the sign and just simply take the magnitude and compare it with the normal quantile. And now because we are doing a 2-sided test, so we need to allocate alpha, separate it, partition it into half, and allocate it to both sides of the distribution. So we have this normal quantile. And for this 1-sided hypothesis, because we are testing towards the right side of 0, so we reject the null hypothesis when the test statistic is greater than this quantile. So similarly, for this 1-sided hypothesis, we have this rejection region. So you can compare this rejection region to the 1-sided test that was explained in last tutorial session. You see the rejection region are pretty similar. Now this is the situation when you are told that the distribution are normal. But even when you are not told that they are normal, As long as the sample size is large enough, you can also do the same thing. Compute this test statistic and also draw the conclusion according to these rejection regions. Now there is another situation when the samples were drawn from the normal distribution, but this time the population variance are not provided, and this is actually a common case. We don't know the population variance, but there were also two different situations whether you assume them to be equal or not, just like in constructing the confidence interval. So if you assume that the two population variants, although they are unknown, but you assume that they are actually the same, then we will have a common estimate of sigma because they are the same, assumed to be the same, so we have a common sigma. And it is estimated by using the pooled sample standard deviation, which is the one that we computed for the confidence interval. So it is combining the two sample variants together, divided by this, and then take the square root. And this is the so-called t-test statistic. And this will be the similar rejection region as before. The difference is that this time the normal quantiles will be replaced by using the t quantile, which are obtained from the student t distribution, with the degrees of freedom equal to the sum of the sample size minus 2. Also, the t quantile we used it for computing the confidence interval for this case. So doing tests and calculating confidence interval, actually the procedure are very similar. Now, suppose we have two samples drawn from the normal distribution. The population variance are unknown and also not equal. You can assume them to be equal. Then, the test statistic this time, we are not combining these two sample variants together because we don't have a common variance to be estimated. So we estimate them separately. So it is just exactly as the same form of this test statistic. The difference is that these two are unknown, so we estimate them using the sample version. And the quantile this time will be also used from the quantiles from the t distribution. But this time, the degree of freedom A will be computed and actually approximated by a very complicated formula. Also, the same procedure that we will use for confidence interval. Now, of course, in most of the situations when the sample size is large, this quantity computed will be also large, so that this t quantile can be well approximated by the normal quantiles when we have large samples. Finally, we have the test for comparing two population proportions. Now, for testing the two population proportions, this is the test statistic that was stated in the lecture notes and lecture video. But I guess in some examples or in the solution of this worksheet, you will see another formula. Now, both formula can be used. Although the value of them computed, the observed value will be a little bit different, but it won't be different by too much. And this also takes the form of the estimate of the difference between these two population proportions and then divided by the standard error. This x bar and y bar represents the sample proportion from the x sample and the y sample. And in this formula, we use a so-called pooled sample proportion, P bar. This P bar is actually based on the null hypothesis. Because if the null hypothesis is true, the proportions are the same. So we have a common proportion. So we can just simply pool the two samples together to treat this as a single sample and estimate the proportion using this common value. So this is the idea how we'll formulate the test statistic in this form. I talk about this just because somehow you may also see this in some examples or in the solution of this worksheet. And you also see this kind of version of the formula in some reference book. And the rejection region will be just the rejection region based on the normal quantiles. Any question about all this test procedure? So this basically will be the test procedure you will see, you've learned in this course, and probably will see in the final assessment. So now in this worksheet, there are all problems related to this test. So probably I will show you, we can work together on a few of them. Maybe you can start working on question number 2. A typical question in doing 2 sample tests. And then I will show you the brief walkthrough of this. But you just try to attempt it first.
Oh yeah, I didn't come last week.
That's a bit insane.
Is tomorrow not the secret? I'm just going to do the lecture online. Yeah, I can't go to school. It just feels like after 6 hours at school. That's such a little something to do. This is the last time I do it for it's quite simple. Yeah. It's just so crazy. I think it's when you're in yeah, no. I think 20 is also. Yeah. And it was like 3 weeks after. And it's just the way yeah, I kind of just check the sheet first rather
one minus half over 2 because the is whether there's a difference. So when you know it's not equal to 2, it's
Is it the one?
suitable than before. Oh yeah. Oh, you want it? Like this.
Yeah, so that's I think she's
That's nice way.
I think have you seen that copy shows it's got box sheet copy. I don't know actually, I like Google it.
I guess you've got something to follow. Yeah, that's why I wish this well, this would because I like it. I don't come here how to do it. I want that kind of thing to be best. It's every so that's all. I get confused with the calculator.
So it only goes up to 3.
It's just
They're not kind of something possible. Yeah. Could we just still listen to calculation? Which one is it?
The one on the path equation. I got these back and it was like, you confused castle with the limit. So no wonder you got the answer wrong. And I was just like, okay.
Yeah, it gets confusing
And
when
9/7 is just
they do like the
1900,
same
so it
Latin
works a bit.
in one problem.
I got 1.28.
Oh, so it's I bet I like
What
slide
for
that.
the
So I can see most of you can get it right for the first part, at least. Now for this kind of question, you see, we are doing a test. But the first step is to identify what hypothesis we are going to test. Now the null hypothesis, of course, obviously is the equality of the two population means. But what is the alternative hypothesis? Now this is essential because the test procedure, how we will use the test statistic to draw the conclusion depends much on your formulation of the alternative hypothesis. So you also need to identify it. Now for some question, as in question number 1, for example, the hypotheses are explicitly stated for you, so you know that it is a one-sided test. But for some question like this, the hypotheses are not explicitly stated, so you need to identify it yourself according to the description of the problem. Now, in particular, when you read through the whole question, you will find that there's only one sentence mentioned about what we are going to test, whether there is a difference in the mean tile wear for the types A and B. So we are only interested in the difference. And there's not a particular direction of the comparison that we are interested in this question. And therefore, the alternative hypothesis that we are going to test will be this two-sided hypothesis. Okay? So this will also affect what kind of rejection region we are going to use. Now in part 1, we want to do the test and we need to identify which test statistic we should use. So we find that in the question it is stated that the samples were drawn from normal distribution. And we are also given the variance. So the population variance alone, they are all equal to 1.742. And therefore the test statistic will be the z-test statistic. Which is the difference in the sample means divided by the sum of this, but both of these variance are equal to the same value, 1.742. And we'll reject the null hypothesis if the magnitude, because we are doing a two-sided test for a two-sided hypothesis. So we use the magnitude only, without the sign. And we reject the null hypothesis if the magnitude is greater than this quantile. Now we use 1 minus alpha over 2 to determine the quantile because for a two-sided hypothesis, we need to allocate half of alpha to both ends. And for 5% significance levels, alpha is 0.05. So the critical value for the test is 1.96. So now the rest will be routine calculation. We substitute everything we know into the test statistic. So we can find the value of this test statistic. Now don't forget we need to take the magnitude of this, although we know that the magnitude of this is just the same value. But even if you find that it is negative, we will just drop the sign for a two-sided test. So we find that it is no greater than the critical value. It didn't fall into the rejection region. So we can draw the conclusion that H0 is not rejected. So this is a typical flow of the procedure in doing a hypothesis test. State the hypothesis, find out the correct version of the test statistics to be used, determine the rejection region, compute the value of this test statistic, draw the conclusion. So we don't have enough evidence. That means we don't have enough evidence to reject the hypothesis that they are not the same. Now in part 2, so this is part 1, okay? So in part 2, we are asked to find a probability, the probability that the test will incorrectly fail to reject the null hypothesis if the true difference is actually equal to 1, not 0. So this will be a probability calculation problem. So we want to compute this probability, not reject the null hypothesis when the difference is equal to 1. Okay? We want to compute this probability. Under this scenario, the probability of not rejecting H0. So first step is to identify under what situation we will not reject the null hypothesis. This is the test statistic, right, with the long variance and sample size. Okay, so the denominator, we know the denominator, but we don't know the numerator because it is talking about under what scenario we are going to not rejecting the null hypothesis. We will not reject the null hypothesis if the difference in the sample mean divided by this, we have a magnitude no greater than 1.96. This is the situation that we will not reject the null hypothesis. So the question is actually asking us how likely this will happen if the difference in the population mean is equal to 1. So this is equivalent to this test statistic is no greater than 1.96 and also no smaller than minus 1.96. Because if this is smaller than minus 1.96, then the magnitude will be greater than 1.96 and will lead to a rejection. We will not reject the null hypothesis when this difference is not too large and not too small. Okay. So we need to compute this probability. Based on the assumption that the difference in the sample means is equal to 1. Now note that this one is a normal probability calculation problem. But this one, this quantity, this test statistic does not follow the standard normal distribution if the difference is not equal to 0. If the difference is equal to 1, the average of this, the mean of this is not equal to 0. So it does not follow the standard normal. We need to standardize it into standard normal based on this quantity. So this is a typical way to do the standardization. Now this quantity, after we center, we subtract the difference in the sample mean from the difference in the sample mean, this test statistic, this time this statistic will become a standard normal random variable. Okay? And since we assume that the difference is equal to 1, so that on the left hand side, on the right hand side, we can adjust accordingly. So the logic here is that we want to compute this probability and we want to make use of the standard normal distribution for us to do the calculation. So that we standardize this one using this assumption. So we subtract mu1 minus mu2 from the numerator here. So this will be centered to become a standard normal random variable. And because we are going to compute this probability, so in the inequality, we need to do the similar adjustment on these two constants, so that this inequality will not change. It will be equivalent, so that the probability will be the same. Now this and this can be computed, so that this will become the standard normal CDF at minus 0.719 minus this one. This number is this. This number is this. Okay? After we standard this become a standard normal random variable, this will become a normal probability using the CDF of the standard normal, putting this quantity into the CDF, this quantity into the CDF, and take the difference, we can get the probability in between. And this will become 0.24. So this is actually quite similar to the one of the questions you've seen in the last worksheet. Although that is in one sample case, this is two sample case. But the flow of the logic, the procedure will be still the same. A typical kind of question that you are asked to compute such probability. The probability of non-rejection based on a particular assumed quantity of the parameters. In fact, this is actually the type 2 error probability. Because under this assumption, the null hypothesis is not correct. The null hypothesis states that they are the same. So if the difference is 0, 1, that means that they are not the same. So the alternative hypothesis is correct, assuming the alternative hypothesis is true. But we do not reject the null hypothesis, and that is the type 2 error. So this is an example calculating the type 2 error probability. And we have 24% chance to make this error. Is there any question? Now, for the other question, question number 1, question number 3, and even question number 4, they are quite similar to do this two sample test on the mean. So we just go directly to question number 5, which is a question involving the population proportions. Now this is actually quite straightforward. Maybe you can just spend a little time try to attempt this question. But the first step, as I mentioned before, you need to identify what hypothesis we are going to test. Okay, so actually this question will be quite straightforward as long as you will be able to identify the correct hypothesis to be tested. Now, in this question, according to this sentence, we actually have a direction that we are interested to compare. Okay, we want to see whether the proportion among those who have attended college is higher compared to those who have not. Okay, so it is not a two-sided test. Whenever we have a particular direction of the comparison that we are interested, then that will become a one-sided test. But it doesn't mean that now alternate hypothesis will be P1 greater than P2, because that is a trap. According to the description of the question, a random sample of N1 yield 100 people, so it is the first sample, are actually obtained from the adult Americans who did not attend college. So did not attend college, this group of people, they are the first population. And the second population is is consisting of those who did have attended college. And therefore, the alternate hypothesis is actually P1 less than P2. Okay. And the test statistic, as I mentioned before, there are two versions, and here I use the version that you see in the solution. Maybe I use X1 and X2. So in the numerator, we also have the difference in the sample proportions. But in the denominator, instead of using two terms combined together, we use a combined sample proportion. This pooled sample proportion can be obtained by combining everything and treat it as a single sample, and then compute a single sample proportion. So we have the sum of these two counts divided by the total sample size. And we will reject the null hypothesis if the test statistic this time, according to the alternate hypothesis, is testing towards the left-hand side. So we reject the null hypothesis if the test statistic is too small compared to this compound. Okay. And for 5% significance level, now this time we don't need to divide alpha by half because we are doing a one-sided test only one direction. So for 5% significance level, the critical value is minus 1.645. So we compute everything from the sample data. So for the first sample, the sample proportion is 0.37. For the second sample, 0.47. And the pooled sample proportion is the overall count in the pooled sample divided by the overall sample size. Then we pop everything into the formula. So this will be the value of the test statistic based on the data. and we compare this with this, we find that this is actually larger than this. So it didn't fall into the rejection region. Okay? This is the rejection region. Smaller than this is the rejection region. And this quantity is greater than the critical value. So it didn't fall into the rejection region. So we don't reject the null hypothesis. The data did not provide enough evidence to claim that P1 is smaller than P2. Or on the other side, P2 is greater than P1. This didn't get support from the data. Okay. So I just want to remind you that in answering such kind of question, you need to, if the hypotheses are not explicitly stated, you need to identify it first, because that will affect how you draw the conclusion. Okay. Now, as I mentioned before, the test statistic, there are two different kind of formula that you can use. Both are valid. You can either use this one or you use another one. You can try to use another one, which is this one. That is also mentioned in the lecture notes. You will find that the value will be quite close, so that you will draw the similar conclusion. Okay. Is there any question? Okay, maybe if you have time, you can try to work on the other questions that are quite similar, and you can also read the solution. Just in case you encounter any problem when you do your revision, do the work on this worksheet, or when you work on some past paper, just feel free to ask me. You can send me an email, or you can make an appointment with me, so that we can have face-to-face discussion. Don't ask me for solution, because I don't have either. But if you get stuck in working on those questions, I can give you some guide. But you need to provide me the solution, because I don't have the paper either. Okay? So thank you for attending this class. Good luck to your final assessment.
But if it's the same as that one, I don't know how to.
Yeah, I need
Yeah. Thank you.
Sir?
Cheers.